Hurricane Irma is history, but unfortunately, folks will be picking up after this storm for a long period of time. It caused a lot of damage across the Caribbean and to Florida and even into Georgia as well. It was a massive hurricane, twice the size of Hurricane Andrew, and powerful. Winds were blowing 185 miles per hour for 37 hours straight. No hurricane on Earth has ever been recorded doing that before. So this indeed goes down in the record books as one of the most powerful hurricanes Earth has ever experienced. Here's the answer to the $1 million question that would have been lovely to have days before the hurricane made landfall, especially in the state of Florida. The hurricane developed off the coast of Africa back on August 27th. It then traveled for thousands and thousands of miles across the Atlantic Ocean, taking 2 weeks to do so. And then right when it got to the longitude of Florida, it said, hey, dude, let's turn north and move across Florida. Everybody loves Florida, right? Well, it did so, and it knocked out a lot of power. In fact, more Floridians lost power from this storm than any other storm on record. And it was a difficult storm to forecast as well, being that it did move west for so many miles. When exactly was that turn to the north going to happen? And where exactly that occurred made a big difference. Was it going to go up the east coast of Florida, the west coast of Florida, and exactly where it went determined who would receive the most damaging wind and storm surge. And again, as you can see, thousands of miles of movement to the west. Exactly when it turned to the north was a very difficult question to answer. Now, it's not unheard of for storms to move from southern Florida up to northern Florida. That happened back with Hurricane Donna. Here's Donna's path back in 1960. Here's Hurricane King back in 1950. A storm tracked from Miami Beach up into Georgia and Alabama, very similar to what we saw with Irma, and caused a lot of devastation. In fact, over $300 million worth of damage. And that's back when there weren't really a whole lot of folks living in Florida. So this storm was a devastating one, and one that ended the hurricane drought that Florida has enjoyed for many years. So one of the questions I hope to answer is, can we learn from this hurricane, learn the model biases, learn which models are most accurate, so that we can use this information to more accurately predict where the next hurricane may happen or where it may go, whether it be 1 month from now or 1 year, 10 years, 20 years, or we can even hope maybe 50 years would be the next hurricane that the United States, or Florida in particular, will have to contend with. So there were a couple of big weather systems that were basically pushing on the storm and telling it where it was going to go. We had the Bermuda High in the middle of the Atlantic Ocean. We had the big high pressure right over the middle of the country, and a little bit of a weakness between these two high pressure systems that helped to do that little pivot once it moved inland. So the Bermuda High, again, pushed the storm westward right over the Caribbean, and then that little weakness in the low pressure system in the trough right between the highs helped to curve the storm from Marco Island to inland Florida and back northwestward again. It moved northwest because it bumped up against this blocking high, which the models did pick up on, but the exact timing, the exact strength of all of these huge weather systems that stretch nearly 5,000 miles wide determined exactly where the storm was going to go. Okay, this is what the European model was predicting 7 days before the hurricane actually made landfall in Florida. So back on September 3rd, it was predicting the storm would go right over the Bahamas and not make a direct landfall in Florida. By comparison, here's the GFS model. It was predicting the storm to go over the Bahamas as well, and then turn off to the north, and then move into the Carolinas. Both models pretty similar in agreement. I might have to give the edge to the GFS on this one because it did have that turn to the northwest. So day one, let's give it to the American model, the GFS model. All right, here we are on September. This is what the model predicted on September 4th. The European had it closer to the United States, making landfall perhaps right around West Palm Beach, and then moving to the north-northwest. So its track drastically changed and became much more accurate to what would eventually happen. By comparison, the GFS model that same day, back on the 4th of September, predicted that the storm would move over the state of Florida, in fact, the east coast of Florida, and then perhaps go back into the Atlantic and make a turn off gradually to the north and maybe even a little northeast a little bit. Gotta give this one to the GFS as well. It had a path that was just a little bit farther west, so the second day of forecasting actually goes to the American model as well. All right, here's September 5th and what the model was predicting. This is a European model, and now the model's saying, uh-oh, we're going to look at the storm on the west coast of Florida. So it had the storm tracking right up the middle part of the state and then kind of turning off to the, actually going straight up north for the most part. And this is really pretty close to what happened. So the European model back on September 5th, 5 days before the hurricane actually hit, did a very good job of predicting where that storm would make landfall. Here's the GFS model by comparison. It had it going up the east coast of Florida, which we know was not the most accurate path. So this day actually goes to the European model. All right, so here's the European model on September 6th. It decided to stick with a somewhat similar path of moving the storm pretty much over the middle part of the state and then curving back off to the northeast. So really not too bad of a forecast by the GFS or by the European model. Here's the GFS model. It had the storm going a bit farther east. So we have to give September 6th, I believe, to the European model run. All right, here's the European on September 7th. Again, we're back to making landfall perhaps around Everglades City and then moving pretty much due north right over the spine of the state and then moving off to the northwest. Again, a very good forecast by the European model, this one being about 3 or 4 days out from when the hurricane made landfall. By comparison, here's the GFS model sticking to the east coast of Florida as its most likely track. Got to give this day, September 7th, to the European model as well. All right, here's the European model. This is Friday the 8th. Again, the storm made landfall in Florida on Sunday. So this is Friday, heading into the weekend. Everybody's wondering where the storm's going to head. Again, the European model had the storm making landfall right in southwest Florida, perhaps right around Everglades City, and then tracking over the spine of the state, and then making that turn off to the northwest once it hit that blocking high pressure system. By comparison, the same day, here's the GFS tracking right over Everglades City, perhaps making landfall a bit farther westward, maybe close to the Marco Island area, and then tracking right up the middle of the state, and then making that turn to the northwest. Pretty close call with this one, but I might give the edge to the GFS, the American model, because it did have the landfall just a tiny, tiny bit farther west. Here's a look at the European computer model run. This is on Saturday before the hurricane made landfall, so lots of eyes on this model trying to predict exactly where the storm's going to head. And kind of concerning, it shifted the path westward, actually having the storm out in the Gulf of Mexico, which would be a worst case scenario for the entire Tampa Bay area, allowing the storm to remain stronger for a longer period of time. This also would have destroyed Fort Myers Beach and Cape Coral and many beaches in Tampa Bay as well due to the storm surge that would have occurred with this particular model run of the European. So not something you want to see the day before the hurricane makes landfall, being predicted by one of the more accurate models that we have access to. By comparison, here's the GFS model making a very accurate prediction of a landfall in Marco Island. So it actually nailed that landfall the day before. So kudos to the GFS. And then it makes a track right up the west coast of Florida. It didn't really predict that little shift inland that we had from Marco over to Hardy and Polk County, but it did predict a path right up the western part of the state. Got to give it to the American model the day before for predicting it most accurately, as it did not have the storm over the Gulf of Mexico, but still, even it did not predict that little wobble that did occur right over, again, Hardy County and the central part of the Tampa Bay area. All right, here is the European model run the day the hurricane made landfall. It's still a little bit too far west. It has it almost making landfall right over the Cape Coral area, so a bit too far west. This would have been a very dire situation. This would have been one storm that would have caused billions of dollars more of damage to the west coast of Florida. And unfortunately, well, I guess I can say fortunately now, more people would have died from this event, but since this did not happen, there weren't as many casualties as likely would have happened due to the storm surge. That was the European. Here's the GFS model making landfall right around Fort Myers and Cape Coral, and then a track a tiny bit farther east. So almost have to give it to the American model on this particular day, the day the landfall occurred, because the storm was a bit farther east. But again, neither model really picked up on that little wobble that happened and moved the storm inland over Marco and then over Hardy County and over Polk County as well, and then back to the northwest. But again, I think I have to give it to the GFS on this one. So really, neither model sticking out as the profound winner of the storm prediction, and there are a few things that could perhaps be enhanced or done better with these storms. And I think as we get more powerful computers that can operate on a better resolution on a micro scale, I think perhaps these models might be able to predict these little wobbles that will occur with this hurricane. If you watched any of my forecasts leading up to the hurricane, I'm sure, saw me use the HWRF model. In my opinion, the most accurate hurricane models would be the GFS, the American model, the European, the HWRF, and also debatably the CMC from Canada and the UK Met as well do wonderful jobs. But here's a look at the HWRF. I wanted to show you how it performed for this hurricane prediction. So the purple line, you see the purple line right here, that's actually the prediction from the HWRF model. The red line is from the National Hurricane Center, so that was their forecast track. The black line is the track that the hurricane actually ended up going on. So here we are. This is the forecast that was issued on September 1st. So on September 1st, the HWRF actually out forecasted the National Hurricane Center really well, actually being very close to where the hurricane actually ended up going. Here we are on September 2nd. HWRF still outperformed the National Hurricane Center, doing a pretty good job, but both the Hurricane Center and the model are predicting a bit too far north, and that would influence when they think the model would recurve, and that is why we saw the storm forecasted to initially go up the east coast of Florida. All right, here September 3rd, HWRF doing good. The National Hurricane Center has a very good forecast as well, both of them heading for the Bahamas. Heading into September 4th, the National Hurricane Center is catching on that we're trending to the south, so they take the path south, and so does the HWRF, but the HWRF is too aggressive with it, and the purple line here taking the storm over Cuba. The storm would have weakened a lot more had it taken this path over Cuba, but still, both models not doing too bad, or both models and the Hurricane Center not doing too bad. Here's a look at September 5th and what the Hurricane Center was predicting, and the HWRF. HWRF took it a little too far north and then took it a little too far south. This would have been a bad scenario had the storm gone into the Gulf of Mexico. It would have redeveloped and perhaps been a stronger storm that would have impacted maybe the Panhandle or the west coast of Florida. So not a great run by the HWRF on the 5th. Here we are on the 6th and got the windshield wiper effect. Now we're looking at the storm possibly going up the east coast of Florida. So instead of possibly going in the Gulf, the HWRF has a storm perhaps not even making landfall off the coast of Miami. So that makes for confusing forecasting when the models are shifting that much. But obviously when they're shifting that much, that gives you an idea that they really don't have a good grip on the storm quite yet. Here's September 7th, and you see that we're starting to see the model trend back towards the west a little bit, with the HWRF actually making a possible landfall right around West Palm Beach. Here we are on the 8th, and okay, so now we're 2 days out from landfall, about 48 hours from landfall of the storm, and the HWRF seems like it has a pretty good grip on where the storm's going to head. For the most part, doing good of having the storm right up over the Marco Island area. Notice that it is making that curve inland a little bit too, like happened with the storm. We didn't see this on the global models, the GFS and the European. That's because their resolution probably isn't good enough to pick up on these minute details. The HWRF is a 3-kilometer model versus the GFS, which is a 28-kilometer model. Basically like high definition TV versus standard def. More resolution is a good thing. The greater resolution you have, the more it's going to pick up on the minute details in the atmosphere. So the HWRF with the high resolution was able to pick up on that we might have a bit of a turn to the inland and going up the spine of the state, which is exactly what happened. We had that turn inland. So that should have been a clue 48 hours out that the storm was possibly going to curve inland over the state of Florida. All right, this is a day before the hurricane. The HWRF takes a bit of a step back and has pretty much a track right up the west coast of Florida. Again, not real great the way it's kind of shifting back and forth with the path here. Not real great consistency with that. Until the morning of the storm, the model did a pretty good job, but it had the curve inland a little bit. So again, the higher resolution definitely contributing to the picking up on the storm moving inland kind of towards that trough that I showed you earlier between the two high pressure systems, but still not quite far enough inland. And this is the morning of. It had it making landfall perhaps in the Cape Coral area, and it did end up making landfall on Marco Island, which weakened the storm some for folks in the Tampa Bay area, which I know if you live in Hardy or Polk County, you would find that debatable, but nonetheless, it did weaken the storm a little bit because it moved over inland and made that curve inland. So HWRF making that farther westerly track would have been more devastation. So there was very high storm surge forecast by the Hurricane Center and some models due to this westerly track for Fort Myers and Cape Coral, and that had to do again with the path going farther west and as opposed to the track going inland like it ended up doing. For the most part, though, HWRF did a pretty solid job. Okay, so which one of the two big powerful models performed the best? Well, 7 days out, the GFS, the American model, performed better than the European. 6 days out, the American model. 5 days, 4 days, 3 days out, the European then took the lead and performed better. 2 days out, the GFS and the European did pretty well, but then the day before and the day of the hurricane, the GFS, the American model, performed better. How about the HWRF model? Well, it actually started out very accurate, right on the path, a good 9 days out from the storm. Kind of lost its way a little bit as we got about 4 to 3 days out, and then about 1 to 2 and the day of the hurricane, it actually had a pretty accurate forecast, even picking up on that little bit of a shift eastward that we knew would eventually occur. Okay, so here's the bottom line on which computer model predicted the storm better, the American model or the European model, and also perhaps a thing or two that we observed or noticed about these computer models that might help us know their biases and what they're good at, what they're bad at, so that we can more accurately predict the path of a hurricane if we end up having another one. And hopefully it'll be a long, long time before we do, and we won't have to worry about these predictions. But nonetheless, always good to try to improve your forecast as much as possible, especially based off of any large weather event like this. So which model performed better? In this case, as we saw, the GFS, the American model, actually outperformed the European for this particular hurricane, even being that the European has a very good track record. Key points. As we're looking at accuracy, the models predicted very well 2 to 3 days out from the landfall of the hurricane. And beyond 3 days, the models gave us kind of a good ballpark of where the storm was going to be, but the accuracy really didn't come in until about 2 to 3 days away from the event. So what you want to do is look for model consistency. If a model is consistent from run to run, from day to day, then that is more likely going to be the solution. Or model trends. If you see that a model continues to trend towards the west from model run to model run, day to day, then it's more likely we're going to see that solution end up being the type that occurs, that it's obviously picking up on that trend for some reason. So consistency and trending is important in forecasting the path of a hurricane. Of course, the National Hurricane Center has a forecast cone that goes outside of where they're actually predicting the center of circulation to be, and that's for a reason. The forecast will likely wobble, as we saw by looking at some of the graphics there. We did see some windshield wiper effect from the storm going to the east coast back to the west coast, so the forecast cone is there for a reason, preparing inside the cone is important for everybody. Even if it looks like the storm is going to go farther to the east or west, it could still end up impacting anybody within that forecast cone. We saw that high resolution models like the HWRF, which has that 3 kilometer resolution, can pick up on more minute shifts that are likely to happen in the atmosphere. So we can look at these models as kind of a guidance as where we could possibly see a hurricane shift inland. For example, the Marco Island event, where it hit Marco Island, the storm then moved inland towards Polk and Highlands County. The global models, the lesser resolution models, did not have that shift inland. So that's something we could have picked up on with the HWRF model. And as computer models do increase in power, the global models like the GFS and the European will increase in resolution and be able to match the HWRF and be able to pick up on those more minute trends in the forecast, and also have the power that they have in forecasting these hurricanes. So there is a bright future for the increasing accuracy of computer models. But one thing I want to end all this on is that models are great for guidance. Obviously, we were looking at these models to help guide us towards a solution for where this hurricane was going to go and where it was going to make landfall. But you can't beat a human forecast. Humans and meteorologists do use models for a lot of guidance, but we can use the biases that we know about these models, that we learn about them, to help predict a forecast that will be more accurate than any computer model can do. And that's true even on a day-to-day basis. When an app on your phone says that it's going to be stormy at 2 p.m., well, a human's going to know more about the East Coast sea breeze, West Coast sea breeze, the model biases, and all that type of thing than just a model or solution being spit out from a computer. So keep that in mind, that the human forecast will still likely outperform models in the near term and likely into the long term as well. All right, so that's kind of a thorough look at IRMA, what happened, and perhaps a thing or two we can pick up from it. Hopefully you found this interesting or useful. I try to do this after every major weather event, whether it be nor'easters or hurricanes, to help improve my forecasting and learn the most I can from it. So come the next big storm, we can use that knowledge to hopefully save lives and give people as much notice as possible about what this big weather event is going to do. All right, guys, if you have any questions about anything I went over, feel free to zip me a note. Otherwise, hopefully we won't have another big storm to contend with for a long, long time. All right, guys, have a great day.